All right, this video is going to be a little bit different from the other ones. This is going to preview some things you haven't learned yet about statistics, and this is going to be on the topic of unbiased samples. All right, something you have probably heard about before is a survey, which is a method of collecting information from a population with the purpose of learning more about them. Whenever we talk about population in statistics, we're talking about the entire group that a survey represents. Many times it might be very difficult, sometimes almost impossible, to survey every member of the population, especially if the population is very large. And therefore in statistics, what is normally used is a sample, which is a part of the population that is used in the survey. The goal of a sample is to accurately represent the population. To do that, the sample must be selected at random or without preference. The sample should be unbiased, where each part or opinion of the population is accurately represented. The opposite of that would be the word biased. A biased sample shows favoritism to parts or opinions of the population more so than it should, and therefore can lead to invalid conclusions, which means conclusions that are not accurate to represent the population. So let's talk about some examples. What if you were going to survey just your friends? Sorry, that's going to be a biased sample. What if you were just going to survey your homeroom? Well, that actually might end up being a biased sample. What if you're just going to survey the football team? I'm sorry, get another biased sample. What if you were going to just get volunteers to participate in your survey? Again, that's probably going to be a biased sample. Here's what you need to understand. When your sample is not selected at random or without preference, then the opinions of that group that you chose, they might not accurately represent the population that your survey is about. That doesn't mean these groups that I mentioned here are bad. That doesn't mean their opinions are bad. It just means their opinions might not accurately represent the general population that your survey is supposed to be about. So, how can we get our sample to be random or to be without preference so that it is ultimately unbiased? Well, I'm going to give you two examples of an unbiased sampling method. The first of which is called the simple random sample, which, as this picture suggests, is like putting all the names in a hat and just start randomly picking them out. It doesn't have to be that way, but that's a very simple example of a simple random sample. Now, more commonly in statistics, what is used is a systematic random sample, having a systematic way of getting a random sample. And the way that that is done is where the people or the items are selected by a specific interval. What do I mean by interval? Here's an example. Every sixth person from the population is selected. That would be an example of a specific interval. Let me give you some more examples of a systematic random sample. If I asked every 15th person who walks into a store, that would be a systematic random sample. Every 22nd person who enters the cafeteria at school, that would be a systematic way of getting a random sample. If we're not talking about people, but maybe about computer chips, every 40th computer chip from an assembly line being checked, that would be a systematic way of checking the computer chips. If we're talking about candy bars being made, every 20 minutes a candy bar that was just wrapped is checked for quality. These are all examples of a systematic way of getting your random sample. Now, let's look at some multiple choice problems. Lee will conduct a survey at his school and will select a random sample of students at the school for it. Which sample is the best random sample for Lee to use? You might want to hit pause and read these answer choices real quick to yourself. All right, have you figured out which one is the best random sample? Well, a lot of them look good. A lot of them talk about every other student or every fifth student, or here, every student. Choice D, every fourth student. They all sound good until you look a little bit closer. Choice A says every other student in the drama club. Well, that's being a little bit too specific. That's not going to be a random sample. That could have some possible bias, not accurately representing the general school population. How about every fifth student who enters the school? Well, all students have to enter the school, so that doesn't really have any bias. That's probably going to be the best Choice. Choice C, every student who rides the same bus as Lee. Well, that's being a little bit too specific. Not going to be random if we're only choosing the kids on the bus as Lee. Choice D, every fourth student in Lee's homeroom. Okay, if we're only asking kids in one homeroom, what if that homeroom was like the advanced algebra kids? They might have certain opinions, not bad, but that might not fully accurately represent the general population at the school. So we're looking for something that is not quite potentially that biased, but going to be more general, more random, and choice B is the one that does it. One more problem. Which statement best describes a random sample of all students in a middle school? Again, you might want to hit pause and read these 4 answer choices on your own. Have you figured out which one is the best one for a random sample of all students at a middle school? How about all students on the track team? That's a little bit too specific, not as random as we would like. Probably not the best choice. All the students on the drama club, we just had this in the last example. Again, kids on the track team, kids in the drama club, they're great. We care about their opinions, but we're looking for something more random and not quite that specific. Choice C, all the students who complete an assignment. Well, what about the kids who don't complete an assignment? Of course, we want all kids to complete their assignments, but what about the ones who aren't? That's not quite as random as we would like. Choice D, of all the students who attend a school-wide assembly. Well, pretty much all kids are going to attend a school-wide assembly. So if that's the premise of where we're picking from, and we're picking kids from every third seat is the systematic way that we're getting our random sample from that school-wide assembly. Choice D is definitely the best choice out of these 4. Choice C wasn't horrible, but choice D was definitely more random because it was from all the students attending that assembly.